How do you get started in printed circuit board design? That's a question I get all the time, and I have already solved this problem for you. I've done all the work. I know all the resources you need to go to get your leg up in printed circuit board and PCB design to go from zero to effectively a freelance consultant or even a working professional. I'm talking about zero to high-speed digital design, okay? And all not within 3 years, but more like 3 to 6 months if you are focused mostly or only on that, okay? It will take you longer if you're self-study, self-paced, but this is the roadmap that works for anyone if you're an electrical engineer. So by the end of this video, you'll know the roadmap to become a professional PCB designer. All right, let's get started. All right, so I have this course, and this course is paid. It's like $97, but I'm going to go into the course to show you the roadmap. This is a systematic approach to change your entire life. Like if you want a whole new career, then in PCB design, this is it. So you click on the PCB designer roadmap. I'm going to show you a preview here, and it has this document. So the first step is getting started. You want to understand the mesh method. I have a video on my YouTube channel explaining this, and this is how you collapse time dramatically and this is my proprietary method. If you see anybody else talking about combine these 4 domains and all that stuff, that's me, all right? And then learn about printed circuit boards, meaning what is their fabrication process? Okay, so you want to understand the fabrication process of a PCB. Become aware of the terms when it comes to printed circuit boards, right? So the words used here, PCB Way is a good YouTube channel that explains and shows visuals. CRS Circuits is also good. So our company, like our manufacturers of the PCBs, they have great content. They manufacture our PCBs, they fabricate them, so they know the best, So you're going to want to understand what is the process of making a PCB. Look that up. What are the terms for PCB? Once you understand those, then, and before then, of course, understanding what are the domains, the key domains you need to be aware of in the first place to get good at PCB design, and to even be able to qualify for an interview for a PCB design role. Like, this is no joke. I probably need to do another video decoding what these PCB roles really mean, because it's a lot of stuff. Anyway, once you understand that foundation, you want to do a project. Your project, I recommend it be a 2-layer printed circuit board. Maybe do a project in KiCad, right? So here I have linked a project that you do in KiCad, right? That I'd recommend, that I've done some research on and yeah, that's good. You can do a project in Altium, like a quick start tutorial, or an OrCAD quick start. That's a good one right there. Easy EDA Essentials. Whatever software you're using, do a PCB, okay? 2 layers good. Once you're done with that, you want to read the Hitchhiker's Guide to PCB Design. This is their ebook, right, from EMA Design Automation. Finish reading up to chapter 4, blah, blah, blah. I'm going to skip that part. Okay, once you're done with that, then you're ready to understand and learn designing for manufacturing. But before that, learn manufacturing of a PCB, okay? There's a DFM handbook, okay? There's also, you want to look up assembly. So the DFM handbook would be from Sierra Circuits. There's also the Design for Assembly ebook that they have. You want to learn design for manufacturing, design for assembly. Then you want to learn design for excellence, building the Arduino Uno, for example, whatever the case may be. The Arduino Uno, here's a link to there. There's just an example. It could be anything. Here I have my design files in OrCAD, and also like in Altium and other tools. You can, if you buy the course, you can get those. And this would be your project 2, by the way, meaning you've already done project 1. You already have your foundation. By reading all these things, don't skip steps either, all right? Then you're ready for your project 2. You do your thing in project 2. Here's the important thing, though. You want to apply the principles that you learned from design for manufacturing and design for assembly to the project of your choice, okay? DFM and DFA skills, like design for excellence and all that stuff, you can't get around this. You cannot get around this. And you need to do this according to IPC 2221. This is the minimum you need to be considered for entry-level PCB design roles. And shoutouts to Altium for sponsoring this video. Click the link in the description below to get access to their new Altium Designer Develop environment. This is Altium, yes,
But check this out. They have a cloud develop like ecosystem that does so much more. It does like designing. Yeah, that's, Altium Designer and everything. But they have an online requirements portal. There's tasks you can do. There's all these other things, ECAD, MCAD collaboration, as usual, the active bill of materials. And they have other things like the project management, supply chain, that's the bill of materials manager, data manufacturing, so you can check assembly. It's too much to go into. Just check it out. But yeah, click the link in the description below. You'll get a 30-day free trial, and it's a lot more than just your standard ECAD software. This is the modern day hardware design tool that companies need to be using.
And you need to know your constraint manager very well too. Anyway, moving forward. We have electromagnetism. Once you're done learning designing for manufacturing, assembly, tests, and all that stuff, you're going to want to learn electromagnetism. There's a nice article here from Sierra Circuits on electromagnetism, EMI, and EMC. And then I have my EMI and EM signal integrity crash course, right? It's supposed to be $497. Right now it's $297. You can get that. And I'll link it below. That's this course on my website. High-speed digital design. I call it high-speed digital design because to know high-speed digital design, you need to start with signal integrity and EMI. Like, you need to have an in-depth understanding of signal integrity and EMI. Like, seriously, like an in-depth. I'm talking about serious. So it has all this information here. This is my $297 course. I talk about the different layer stack-ups. How do you analyze those? Okay. How do you understand how the magnetic field interacts and propagates?
Signal.
So that's linked below if you just want to jump into that crash course and you already know how to design for manufacturing and all that good stuff. You have your 8-layer stack up, analyzing the 10-layer stack up. All right. The same rules apply, same principles apply to everything. And that's just understanding signal integrity. Your practical applications of EMI and signal integrity, like you need to know part placement, mounting holes, blind and buried vias, making new blind and buried vias in your particular software. What is an engineering change order? Routing cleanup, signal integrity simulation, impedance discontinuities, signal integrity problems, via stubs, all the major signal integrity problems, ground bounce, power routing. Okay. Then you have your intro to high-speed digital design, which is a whole different other different beast. That's just your signal integrity phase. That's the $297 course. All right. Well, EMI plus signal integrity. So if you want to speed things up, you could take my course. You don't have to. Just follow this blueprint. All right. Introduction to signal integrity is here, right? So Sierra Circuits, they have their signal integrity book. Go to the website. You can access that. PCB component placement. They have a nice article discussing that. I also have my placement guide, which you'll get as if you enroll in one of my other courses. Then you have signal integrity challenges and solutions with a multi-layer PCB. And I have a recommended design. You can find a design, build the project yourself once you understand signal integrity and EMI, EMC. Once you've done that, then you're ready for a high-speed digital design. This is where things get crazy. High-speed digital is timing added to the signal integrity and EMI problems. Okay, so how do you get started there? Sierra Circuits has a great book on high-speed digital design, soft introduction to controlled impedance and its importance. What is a controlled impedance? Introduction to controlled impedance, high-speed PCB design materials. You're going to need to know those. Read those books. Then Project 4, you could design a USB A to C converter. It's pretty simple. And then if you enroll in my course, this roadmap, I have a reference design, project files, my modern hardware design process, this document with the 12 phases, PCB design and layout, then modern hardware. Now already you have that. Okay. Project 5 is a document course, essentially, where you have all your designer files, everything, videos showing component placement, routing of this high-speed board in Altium, via stitching, all that stuff. This looks like a simple board. It's not. It's to barely be able to do this board, you need to have your signal integrity and your EMI and your high-speed digital design fundamentals and foundations down pat. You can't go in here skipping steps or not understanding everything with signal integrity and EMI. I'm not kidding, okay? It looks like a simple board. Do not attempt this design without understanding these. Okay. All right. And then you have video recordings. There's like Altium, and then there's the OrCAD version of the PCB. So in case you're using OrCAD X, there's that. There's video recordings. Yeah, I already have those. For your constraints, there are things like your high-speed layout guide, example reference designs, and then this document explains what is USB connector. It also has the bill of materials and all that stuff. What else? You can get design files. What else? In this document guide, I pretty much explain certain things like this component library quick guide. I have a bunch of documents in here. Right. How do you select components and put them into your OrCAD library in case you're using OrCAD. The full bill of materials, what the TVS diode, protection diode does, what are differential pairs, why differential pairs do what they do, PCB materials for this PCB stack up. How do you set your differential pair rules, inter-pair skew and intra-pair skew, just a ton of stuff. That's just one of the projects. How to do length matching and phase tuning and phase delay. So that's all in that one reference design link for project 4. Then components and schematic design. What are some principles there? PCB routing considerations. PCB layout of the project. Right. Yeah, this is the same document. Okay. After you're done with that, there's the power integrity. You need to understand what is power distribution network. Then there are more references and documents here and links. Project 5, pretty much learn power integrity, okay? Whether it's from one ebook, whether it's through Dr. Bogatin's Power Integrity and Signal Integrity Simplified book or whatever, then do that. I know it's a lot of information. You have Project 5B, which is, I recommend, which is a buck boost converter. Once you understand power integrity, do a buck boost converter. And here's an example. Here's the design that I would go with. This is just an example. Do any power electronics converter. All right. Once you're done with that, then you have electronics fundamentals. And there's a good free website, electronics tutorials, where you can learn AC circuits, binary numbers, diodes, and all that good stuff. Then you're going to want to learn about component selection. Sierra Circuits has a good guide. I have a document guide if you were to buy this course that shows you how to select hardware peripherals and components. What are the GPU, CPU, case, motherboards? Why is it important to have proper component selection and component placement? Okay. And these are the requirements, the general rules for selecting parts. What's the availability, the environment, standards, voltage, current, all that stuff. So that's internal. I'm not going to go too much into that. Okay. Introduction to hardware communication protocols. It says coming soon, but I have this done out in videos. So parallel communication protocols and everything. There's a spreadsheet that I have that shows all of this, okay, done by one of our former students. List of hardware communication protocols. These are very important. These are extremely important. Your I2C RS-232, details on those, okay, because you're going to need to know that. And then this is the spreadsheet I was talking about. So this is a spreadsheet that one of my students did, and it has everything from binary to what are the speeds, clock speeds for RJ45 and all this stuff. Power distribution network, notes, rules of thumb, signal integrity. I won't give away the whole sauce, okay? Another bonus, complete checklist for any hardware design. Okay. Product requirements, part library, schematic, board requirements. And you can just go through this checklist and do everything for any PCB. This links to another roadmap document, okay? So this is kind of like a resource guide where you have certain like IPC documents you're supposed to know about and everything. This is the ebook vault. All right. And then you have your advanced PCB layout and integration. Okay. For the BeagleBone Black. And then finally a complete design document guide, multiple document guides that literally show you step by step and explain how do you choose a microcontroller? How do we choose the Satara processor, right? What are the functions? How does it work? Why does it work? Data sheet. What are important aspects of the data sheet to pull from to understand everything about that component? Why do you choose that crystal oscillator? Key parts of the schematic, explain. And in the supplemental notes, we have more things here. How do you choose an eMMC? What is the impedance of Ethernet phi traces? Okay. What is the PCB layer stack up? The vias used, the rules, the constraints, all that stuff. All right. So you get the document. Oh, and also there's career launch. Once you're done with that, I know it took a while. Then you're ready to create the perfect resume. I've created a different approach to writing the resume. This is not your typical resume writing advice. You will not find this anywhere online except in my videos. That's what I did to stop having to apply to jobs, and jobs now apply for me. I get reached out to, I send them my resume. I did this based on marketing and messaging principles in copywriting and blog writing, okay? Because I've gotten my blogs to page 1 on Google before, and that sustained for like a good year and a half until other companies who literally make the software I was talking about started improving their search engine optimization game. But people can still find my website, learnorcadonline.thinkific.com. People can still find my website, okay? And if you want to do a mock interview afterward, that is another fee, or you can get like in a membership. And finally, if you want to, one second. Right. And then, by the way, when it comes to like interviewing for jobs and everything, interviewing is a completely different skill set. The resume writing, attracting recruiters instead of having to reach out to them. These are completely different skill sets. Just because you know everything in the world when it comes to PCB and hardware design doesn't mean you can interview well. And I'm not just saying that to say it. I'm telling you, interviewing is a communication and messaging and sales skills. Okay. So if you want, and you probably need mock interview practice with me, I've helped Stanford graduate students land offers and opportunities that they otherwise wouldn't have gotten simply because of how their presentation was set up, simply because of how the presentation slides and how they were going to do their interview. And I'm like, no, you have all the skills you need. It's just how you're packaging it. This is not going to get you hired. I'll tell you this, every job that I've done a technical presentation for, I got an offer 100% of the time, including my ones at Intel and also at NXP. So I know what I'm talking about. All right. That's the roadmap. Do those steps and you'll be good to go. You'll be golden. If you want to accelerate your hardware design, well, just even have a roadmap in general. This is the document. It's $97. Get it on my website. The link is below. Okay. I should put the video on here. And then if you want to go through the course that accelerates the EMI, signal integrity, high-speed digital design stuff, then you're going to want this course. This is going to go up to $497 soon as we get more people. Right now it's at $297 at an early bird pricing, and then that'll go up just whenever we have enough people to give more reviews and stuff like that. All right. But if there's one course you are to get aside from the roadmap, it's this one. This gives you your signal integrity, your EMI, your EMC, your high-speed digital design, the 2 projects. Okay. This is the biggest hurdle. Then afterward, you could learn DFM or DFX. You can learn DFX before or after. All right. Let me know if you have any questions. Yeah, that's the roadmap. And those are the bonuses you get with the roadmap. Once you do this, you will be well positioned, more than 95% of hardware engineers, to actually land an entry level to mid junior level role as a PCB designer and electrical hardware design engineer who knows what they're doing and will get the offer.